This lesson contains audio narration. Please connect your headphones, or turn on your speakers. These are the key objectives that you can expect to achieve after completing this lesson. Describe the documentation required to control the ordering, delivery and issuing of production materials and welding consumables. Determine if a welding procedure specification has been properly qualified. Verify the qualifications of the welder or welding operator. Establish if a welding operation has been carried out in accordance with an approved welding procedure specification. Identify items that a welding inspector should check prior to, during and after welding. Prepare inspection reports. Click the Next button to proceed. The functions, responsibilities and accountability of the inspector can be wide-ranging. An inspector could be employed full-time by the contractor performing the work, quality control, or could be employed by an inspection organization acting as a third party and reporting to the owner or designer, quality assurance. An inspector may simply inspect and monitor welding operations, or may be involved in many other aspects of inspection, including material inspection, measurement of shape, machining inspection, heat treating operations, proof testing, and reporting on progress. The inspector's role begins well before welding starts, continues during the welding operation, involves action after the welding has been completed, and is finished only when the results are properly reported. As part of a quality management system, inspection activities are defined in an inspection and test plan, ITP, which clearly describes what is required and is usually agreed upon by the vendor and the purchaser. The inspector is responsible for producing documents that ensure the traceability of the components and related fabricating action. A formal inspection and test plan is a document that details the inspection sequence and schedule agreed upon between the purchaser and the vendor. This is a continuation of the inspection and test plan shown on the previous slide. Prior to welding, the inspector must ensure that the inspection test plan, hold points, and reject reporting are in place. The base and filler materials to be used are correct. The shop has approved welding procedures and qualified welders. Witnessing and monitoring of welding procedure specification or welder qualification is conducted if necessary. Tools and equipment are suitable for the job. And joint fit-up, cleanliness and alignment are suitable. The quality triangle for welding shown in the figure identifies 3 key items that should be verified by the welding inspector prior to beginning any welding. Correct materials, approved welding procedures and qualified welders. During production welding, the inspector must verify that welding variables such as current, voltage and travel speed are in compliance with welding procedure. The quality and placement of individual weld passes and layers is acceptable. Interpass cleaning and temperature are acceptable and the heat input is monitored. Back gouging or grinding and repairs of welded surfaces are acceptable. And any in-process non-destructive testing and visual inspection is conducted and documented. The following figure shows a welding inspector checking a fabricated item against the drawing. After production welding is complete, the inspector must verify finished weld appearance, including uniformity, weld size and soundness. Verify dimensional accuracy of the overall welded assembly. Conduct surveillance of additional non-destructive testing, post-weld heat treatment or pressure testing, if required. And prepare inspection and related reports, including supplementary photos and equipment printouts. Weld inspection is an important part of the overall quality management system of a fabricator. There are 2 levels of quality activity. Quality control refers to the controls that are applied at each stage of a manufacturing process to consistently produce a quality product. In the context of weld inspection, quality control means visual inspection, checking documents, verifying compliance with the welding procedure specification, selecting areas for non-destructive testing, verifying compliance of the base material and the consumables being used and other similar functions. This is usually carried out by the manufacturer or fabricator. Quality assurance includes taking all planned and systematic technical and administrative actions necessary to assure an item, or service, is being produced to an optimum quality level. In weld inspection, this means verifying that personnel, including quality control personnel, are properly qualified and documented, that material handling, welding and inspection is being carried out in accordance with approved procedures, and generally checking that the entire process is documented prior to welding and after all repairs have been completed. When preparation, production and inspection are over, the inspector must collate the observations, checklists and results into a report that is structured to meet the needs of the client, a jurisdiction or a code. This report is the document of reference that could allow the tracing of a production parameter that proves, after years of service, to have contributed to a failure. It allows the tracing of responsibility to a specific supplier or contractor. Reports produced by the inspector should be neat and accurate, complete and timely. Be aware of spelling or grammatical errors. Reports should be legible. In correcting errors on reports or technical documents, the inspector single lines out, dates and initials the error. The figure is an example of a carefully completed report recording details of a weld. Reports should be legibly written and complete. Sketches are often useful. To minimize additional paperwork, standard formats can be used wherever possible. The figure shows an example of a quality plan for the manufacture of a boiler drum. The format includes standard items and reference to existing quality documents by number. Items not required are deleted. The letter R is written in to indicate that a control check is required, and the letter in the box above the R indicates the type of control check. Such a format is easy to prepare, is unambiguous and is easy to follow. The format should be acceptable to the client and meet the requirements of the codes, standards or regulations. The manufacturer's quality manual will often include typical standard forms as part of the document prepared for their authorization for pressure vessel fabrication. These standard forms might include purchase orders, receiving and interim inspection reports, non-conformance reports and disposition instructions. Standard checklists may be used to identify the various documents required in the documentation package required at the end of a contract. The starting point for the control of materials is the purchasing process. Company policy usually dictates whether material is purchased by requisition, local purchase order or formal purchase order. Typically the project engineer or superintendent raises a requisition probably on a standard form. This document should show enough detail to enable the supplier to provide the right material. Information on the requisition might include quantity and dimensions. For example, 3 20-foot lengths of 8-inch diameter Schedule 80. Material specification. For example, ASTM A335 grade P22 stainless steel tubing. Any special requirements. For example, heat treating, quality assurance requirements, or inspection prior to delivery. And requirement to supply annual test certificates. The requisition is typically routed to stores or a central purchasing department where the information is transferred to a formal purchase order, perhaps a local purchase order for small items or quantities. An example is shown in Figure 6, although purchase orders can take many forms. Many quality assurance systems require that a copy of the requisition and purchase order go to the inspection department at the time the order is placed. The inspector should review these to ensure that what is being purchased is in accordance with specified requirements. The inspector might be required to review documentation related to base materials including metallurgy, mill specification, proposed manufacturing plan, heat treatment history and inspection history. Remember that the common CSA and ASTM steel specifications also call up general requirements. For example, Steels meeting any grade of CAN CSAG 40.21 must also meet the general requirements of CAN CSAG 40.20. The latter includes such requirements as dimensional tolerances, marking, repairs and so forth. In construction, manufacturing and repairs, the responsibility of the contractor, manufacturer or owner is usually to meet the requirements of a code of practice that relates to the performance requirements of the end product once it is in service. For materials, these requirements might include specific alloy content for corrosion resistance, notch toughness or strength at high temperatures. Materials shall be marked to prove specification, grade and lead number. The supplier, when requested, provides a mill test certificate, which details the chemical analysis of the material, the mechanical test results and a history of heat treatment and inspection. The figure shows a typical mill test certificate with chemical content and actual mechanical test results, yield strength, ultimate tensile strength and percent elongation. There is no standard format. Each steel mill uses its own design and conventions. Take careful note of the position of the decimal point in the chemical analysis figures. Sometimes these values are expressed as the weight percent multiplied by 1000 to make it easier to read. Be careful to check the units. Values should be expressed in the units of the specification. For example, check whether impact values are in foot-pounds or joules, and compare them to the units of the acceptance values. When the mill test certificates have been reviewed and are found to comply with the specifications, they should be stamped and signed to signify acceptance. The inspector must be aware of who is responsible for conducting heat treatment and on what basis the material is accepted. The inspector should review similar documentation supplied with fabricated components such as welded fittings or piping assemblies. When fabrication has been carried out by others and a component is to be incorporated into the structure or vessel that is the responsibility of the inspector, it must be assured that it complies in every respect with the contract requirements. In the example shown in the figure on the next slide, mill test certificates are required for carbon steel pipe, including coatings, all materials requiring impact testing, carbon steel valves, all alloy and stainless steel pipe and fittings and alloy and stainless steel valves. Mill test certificates are not required for pressure parts that are made in accordance with an accepted standard, provided the parts are suitably marked with a name or trademark. The figure shows materials, receiving, and inspection guidelines. When material is delivered, several items must be verified against the order. Do the materials comply dimensionally? Are the materials properly identified? Do the chemical and mechanical properties as determined from the mill test certificate comply with specifications? Additional tests may be required if the inspector doubts the documentation or if the documentation or material identification is incomplete. The material should be inspected upon receipt to verify its condition. Items to be checked include weathering or transportation damage, corrosion damage due to salt spray if the shipment has come by sea, mechanical damage incurred during shipment or during road transport such as dents and scrapes, and surface or edge defects resulting from material manufacturing. The figure shows typical items to be checked in a physical inspection of material. Now that we have reviewed the material, let's see what you remember. Click the play button. You have completed this lesson. You should be able to define the roles and responsibilities of the welding inspector, identify inspection activities prior to welding, and describe material receiving and inspection. Congratulations! You have completed this lesson.